Good morning, dear student. Now we are going to see a problem of Porter governor. You see this problem. In a Porter governor of a 4 arms is 400 mm long. The upper arms are pivoted on the axis of the sleeve, whereas the lower arms are pivoted to the sleeve at a distance of 45 mm from the axis of rotation. Each ball has a mass of 8 kg and the load on the sleeve, you see that the load on the sleeve is 60 kg. So what will be the equilibrium speed for the two extreme radius of 250 mm and 300 mm of rotation of the governor ball? So you see that this is a simple line diagram of a Porter governor. This upper arm is pivoted on the axis of the rotation. Then the lower arm is offset from the axis of the rotation, that is 45 mm, right, offset. So the R is the radius of rotation of the governor, H is the height of the governor, so A is the distance between the ball to the B. So that is here I take A dash to the G or A dash to B, right. So the distance between B to this this point, the sleeve loading point to this point is B, then this distance is C. Now you write the given data. So given data, right. So mass of the, you know that the length of the sleeve is that arm is 400 mm, then the small m 8 kg, that is the mass of the ball. Here the mass of the ball is 8 kg. Then capital M is nothing but 60 divided by 2, because the load on the sleeve is 60 kg, that so 60 divided by 2, so 30 kg. So the sleeve weight is 30 kg. Some problems, the sleeve weight is directly given, you take the sleeve weight directly. Suppose the sleeve weight is 60 is given, you directly take the 60, but the load is given, so you 60 divided by 2, that is 30 kg, right. So the radius of rotation 250 mm, then R1, then R2 is equal to 300 mm. So in this solution, so first you should find out the in that solution, first case R equal to R1 equal to 250 mm. Based on that you should calculate the speed of the governor. So first you should find out the tan theta equal to R divided by, so tan theta equal to R divided by this, so H, R divided by the H value, right. So H is equal to, so R divided by O A whole square minus R square, right, that is equal to, so 250 divided by O you know that 400, then R you know that is 250 whole square, then finally you are getting 0.8. So what is the tan beta? So beta equal to, so tan beta, you see this, the tan beta, this is the beta, so similarly this is also a beta, opposite angle as a beta. So this is a distance, this is a B distance, so B by A, so B by A. So what is the B value? So here you should calculate the B value. B value is equal to, so you see this is B value. So what is the B value? This total distance is R. So to R equal to 250 minus the offset distance is 45. So you are getting, so 205 mm. So tan beta equal to B value 205 divided by the A value. So what is the A value? You calculate the A value. So A is equal to, so square root of 400 square minus 205 square. So the A value is equal to, so 400 square, this is a 400 square, so this is a distance, so 400 square, so minus 200 whole square root of, you are getting A. So A is equal to, you are getting 343.4 m. Now substitute here, so 205 divided by 343.4, so the tan beta value, that is equal to 0.59. So now you find out the K value. So K value equal to equal to 0.59 divided by 0.8, so you are getting that, so 0.75. So you know the general equation of speed, so n square equal to 895 divided by h, so small mg plus capital Mg plus or minus friction into 1 plus k divided by mg. So in this condition friction equal to 0, right? So this equation may be written as 895 divided by h into mg plus capital Mg into 1 plus k, so divided by mg, right? So g is common for both them, you take it outside, it is cancelled, so it may be written as 895 divided by h into small m plus capital M into 1 plus k, so divided by small m, right? Now substitute all the values in this equation, right? First n1 square, that is equal to 8 and if divided by h1 square into small m plus capital M into 1 plus k divided by m. So what is h? So h is equal, h1 is equal to, so this is the h, according to r1 you should find out the h1. So h1 is equal to, so 400 square minus 250 square, so you are getting that. So the value of r equal to value of h is equal to value of h is equal to 312.4 m. Now substitute in this equation 8 and divided by 0.3125 into capital small m 8 plus capital M 30 into 1 plus k value, you know that k value, it is a 0.75, right? So divided by small m 8. Finally you are getting the answer is the n1 equal to 147 rpm. So 147 rpm you are getting that. Similarly you should find out the n2 also, right? So here, so second case, r equal to, r2 equal to 300 mm, right? So according to the r2 value you should find out the everything. So tan theta equal to r by h, that is equal to r2 by h, so 300 divided by, so OA square minus r2 square, right? So 300 divided by OA, that is 400 because arm length, right, minus 300, so you are getting that 1.134, right? So then B value you should find out. So 300 minus 45, 300 is a radius of rotation minus the offset distance 45, you are getting the B value 255 mm, right? Then what is the A value? So 400 square minus 255 square, so you are getting that 308.2 mm, right? So tan beta equal to, so B by A, so 255 divided by 308.2, that is equal to 0.82, right? So what is the K? K is equal to tan beta divided by tan theta, so 0.82 divided by 1.11134, that is equal to 0.734, right? So now f is equal to 0, you know that the n2 square equal to 895 divided by h2 into small m plus capital M into 1 plus k, so the capital M into 1 plus k small m, right? Now find out the h2. h2 is equal to, this is the h2 equation, so root of 400 square minus 300 square, so you are getting 264.57 mm. Now substitute all the value in the n2 equation, so n2 square equal to 8 95 divided by 0.26457 into 8 plus 30 into 1 plus the k value 0.734, so divided by 8. Finally, so the n2 square, from that n2 square you find out n2 is equal to 159.1 rpm. So therefore the range of speed equal to n2 minus n1. There 159.1 minus 147, so you are getting 12.1 rpm. So this is called as a range of speed. This is the answer for the question.